So the human one is the only species able to build weapons to kill itself. I was really young when I heard this quote from a friend. I was so naive that initially I didn't believe it. Martina Capriotti, marine biologist. I am a researcher, currently based in Italy. And I was born and grew up in a seaside town called San Benedetto del Tronto on the east coast of the mid-Adriatic Sea. And so I always had a special affection for the sea and for the water as an element. For example, I used to swim since I was super, super young. And growing up, I wanted to give a sense to all these years of swimming, so I became a lifeguard after hard training in the rough sea. And I was like 16 years old at that time. And the very same year, I also became a scuba diver. And you know, there are many scuba divers here in the room, so they know the feeling. So the first time you get your face underwater is like, wow. And I had my really first dive in the open water. I got literally mesmerized by the beauty of the underwater world. I was not there. This is not the picture of my really first dive, but still, it was pretty amazing. You know, when you go down there, it's also pretty common to find a human footprint. And actually, that first dive was for me a sort of a dual experience. So from one side, this scene led me it was clear for me that I wanted to become a marine biologist, but also the other aspect, so seeing trash underwater, also helped me to enter in the marine pollution kind of studies and research. So, I don't know, it's probably a coincidence, but since my first internships and theses, I always worked on chemical pollution. So not something that you see like that, but something that is invisible. It's the invisible pollution. I work with many contaminants, like hydrocarbons, pesticides, heavy metals. You probably heard about some of them. However, at some point of my career, I was really interested in understanding how marine pollution was actually, marine invisible pollution, was actually infiltrating in marine life. So I was sort of interested in understanding how microplastic could be transferred and carrier of these chemical pollutants. You probably heard about microplastics. Those are really tiny plastic particles, smaller than 5 millimeters. So basically, in a microscopic world, microplastics are actually really huge, because chemical contaminants are super, super small. Those are like molecules, chemicals, that can have a toxic effect on life. Microplastics, how can they get into the ocean? So we can have the primary microplastics that become so small before entering the ocean. For example, you probably in your life have used like toothpaste with those tiny dots, or facial scrubs as well with the tiny abrasive microspheres. That was plastic. And for years, we introduced into the ocean thousands and thousands of these really tiny particles. But microplastics are also in another form, called the secondary microplastics, that come from the breakdown of larger plastic waste. I was conducting a beach cleanup at that time when I found this trash, this piece of trash. And when I it was a part of a water bottle. And when I collected it, it was literally crushing in my hands, like becoming like tiny fragments. It was not like a water bottle we used to handle. And do you know why? Because even plastic wear sunscreen. Yeah, it's, they don't wear the sunscreen that we know about, but their compounds that act like sunscreen are called plasticizers. So molecules that are added during the plastic production that help plastic to be more malleable, more durable, and more resistant to the environmental condition. But of course, when a plastic bottle ends up into the ocean, starts traveling around the planet, get a lot of sun. And so these plasticizers can pass from the plastic to the ocean, because even plastic get age, get old. I don't know if you ever heard about endocrine disruptors. So these plasticizers had a really special activity that are able to interfere with our endocrine system, the hormonal system. Endocrine disruptor is actually a huge word that identifies many categories of these chemical compounds. Sometimes I like to call them molecular impostors, because some of them, like those plasticizers, act on behalf of our hormone. So look at the picture over here of those two molecules. I know, this is not a chemical lesson, but if you look at the shape of the molecule, you can see how these are pretty similar. So on the right, you have the estradiol. It's our female sexual hormone that every female produces during reproduction or development. And on its side, there is the nonylphenol, a common plasticizer. It's a contaminant that has a similar shape to the estradiol, and indeed is able to act on behalf of the estradiol. That's why I like to call them molecular impostors, because they are making a mess to our hormonal system. And not just ours, even the marine life, marine animals' hormonal systems. But now I want to tell you another story. Among these molecular impostors, there is another one really curious. For those of you that go boating, probably knows that we need to paint the keel of the boat with an anti-fouling painting, because otherwise a lot of life, seaweeds or little marine creatures will grow on the keel. And so until the 80s, one of the main ingredients of this anti-fouling painting was the tributyltin, or TBT. So this TBT was supposed to interfere with the reproduction, the development of the larvae of many animals. But at some point, many scientists around the planet started to observe a dramatic decrease in the population of a really curious sea snail called whelk. They didn't know why at the beginning, but searching a little bit more into deep, they found that these animals have accumulated this TBT. And searching more, they found that the female of this whelk were becoming male. They were undertaking a process of masculinization. So basically, they were expressing characters typical of male. And scientists at that time, I was not born at that time, but they found a penis on the female of a whelk. This is what endocrine disruptors can actually do. So endocrine disruptors can be found everywhere on the planet, in the ocean. Those are anthropogenic, so they are man-made chemicals. And we can also find these chemicals associated to microplastics. I told you about plasticizers a bit ago. But actually, a plastic particle that ends up into the ocean is able to attract on its surface tons of these chemicals that are navigating in the water. So it is called an eco-corona, so a sort of chemical mat all around the surface of microplastics. And so they travel all around the planet thanks to these microplastic pieces. And so I was super interested in this kind of mechanism. So a few years ago, I got one of my projects funded for studying this cocktail of contaminants that were surrounding the microplastics. So I went to the sea, the Adriatic Sea. I collected some microplastic, bring back to the lab. I extracted this cocktail of contaminant. We actually call it cocktail. It's not just something that I just made up. I took this cocktail of contaminants, and inside I found many hydrocarbons, pesticides, and many other contaminants that were present in the water. And then I was super curious to know what is the biological activities of this cocktail. So how all these contaminants could affect life, marine life, but also humans. So I sent this cocktail to some colleagues that have, like in the lab, some cells, an in vitro cell culture. And so they provided these cells the cocktail. The cells were fat cells. And so after a while, they found out that the cocktail I sent them was able to trigger the fat growing and to trigger the deposition of the fat drops inside the fat cells. And so we immediately understood that in that cocktail of contaminants, there were some molecules called obesogens. Obesogens are molecules that are able to promote obesity. Because yes, obesity is not only promoted by eating junk food. This is what endocrine disruptors and metabolic disruptors can actually do. I got inspired by this quote from Rachel Carson. I don't know if you know her. She's not with us anymore, but she wrote amazing books. And she was one of the first ones in the 60s to denounce to the world the concept of the endocrine disruptors. So she used to say, in nature, nothing exists alone. But man is part of nature. And his war against nature is inevitably a war against himself. And that was actually true. And at that point, I realized that that quote that my friend told me many years ago was actually true. But nothing, I strongly believe in the good faith of people. I had the chance to meet in person the amazing explorer Sylvia Hurl in Rome. And during a speech, I was surprised from a quote she was saying. So pollution is negative, but it also has a positive side. I said, what? Which could be the positive side of pollution? The positive side is that we know it, so we can still do something to protect our planet. And yeah, that was like super inspiring for me. And after a while, there was like a word that was orbitating in my mind. I had no idea about the meaning of this word, and then I went to Google it, and I found that it was like pretty far away from the concept I was feeling about this word. It was like a design plan or a technical drawing, probably many engineers and architects were using. But the meaning I was giving to this word was completely different. I think blueprint is a sort of vibe, is a sort of thoughts, ideas that we should associate to every decision we take, to every path we undertake, to every lifestyle we decided to conduct at some point in our life. The blueprint is what we leave behind that take into the consideration the ocean. And this because, pollution starts from our choices. Pollution starts from our lifestyle. Pollution starts from our sense of the nature. Thank you so much. Yeah.